Okay, now we're going to do one of the most important proofs in circle theorems. Okay, so knowing this proof is very important, and even though the theorem itself is not used as often, this theorem gets used to produce a lot of other theorems. Okay, and it's a little bit tricky. Okay, but let me first explain it. Basically, what we have is we have two radii. Okay, see two radii? Now, what we do with these radii is where they meet the circumference, we're going to start at those points, and then we're going to draw two chords. A chord is what again?
That's the circumference.
Good. So I'm going to draw a chord from here out, and then another chord that meets this chord, but from here out. Okay. It's not very pretty, but I think you get the idea. Okay. So basically what it is we've got points on the circumference, okay, which means we have an arc, and this arc has built on top of him a little pyramid. See that pyramid? Okay. And a little bit larger pyramid. And I don't like to use the idea of pyramid, but what I'm trying to show you is that this arc, the word we use is subtends. What's subtends? I'd never know, but whatever. Just means it forms the basis of, it underlines, it's at, sub means it's at the bottom. I think it's subtend. Stend means to extend, okay? Subtend, it means it's at the bottom of. An angle at the center. Do you see we make an angle at the center? And we're making an angle on the arc, on the opposite arc, or on the angle at the circumference. Now the theorem says that this angle at the center will be twice the size. So if this one is x, this one will be twice the size of the angle on the arc. That's what the theorem says. Okay. Make sense? Okay, now let me just draw you some different ways in which this can happen. There's only from these 2 points. If I go from, let me draw the points nicely. If I go from this point and from that point to the center, there's only one angle I can make. I can only connect them, and I have my angle at my center. But the angle at the arc could be anything. So for example, we had this one, but there's no reason why it couldn't have been one here and there. You see, it looks quite different than that one. But if I were to be able to move this point, and I move him here all the way to there, it's still on the arc. Do you see? I don't know if you can almost imagine that like this is a piece of elastic, and you put your finger on the circle, and as you're moving the finger, this angle moves. But still, here's the angle at the center. If this one is, if this is the angle that these 2 points make on the arc, let's say that angle is x, then this one will be 2x. You see that? Okay, let me draw you one more way in which this can appear. Okay. And I do apologize for my very ugly circles. Okay. Now, only imagine that this line here goes and lies on top of this radius. So in other words, I start here, but instead of going there or there, I just follow this line exactly, and I extend it like that. And then if I go from here, it's very ugly. See there. Okay, so it's kind of, I have a diameter and a radius. And then I just connect these 2 points. Okay. Can you see where's the angle at the center? If I name them, can you tell me which angle is at the center and which angle is at the chord? I just name it like AOB or AOC. COB. COB is a straight line. You're not. AOB. Okay, so there's AOB. That's the angle at the center. Which would be the angle at the arc? ACO. So if this one is that size, this one is double that one size. Okay. Okay. If this one is, let me use some numbers. If this one is 10 degrees, this one is 20. The angle at the center, so let me write down the theorem now. Okay, so the theorem is the angle at the center is twice the angle at the arc subtended by the same arc. Okay, this little part here, subtended by the same arc, just means that both of them are made with the same arc at their bottom. So for example, if I draw another angle at the arc here, so you can see there's an angle at the arc, but he is not subtended by the same arc as the angle at the center. You see, this arc is from A to B to create this angle here, but to create that angle there, we use arc, let's call that one D to B. Okay, it's not subtended by, so it has to come from the same 2 points on the circumference. Does that make sense? Okay. Now the proof of this one is a little bit, I don't know, I like it, but it's not as easy as we've had so far. So I'll do it for you. So we're just going to prove the normal case here, and you will have to prove it for any of the above situations. Okay, I'm just going to do the normal one for you. The other ones would work similarly. Okay, so we have center O, we have A, B, C are the points on the circumference. Okay. And I'm just going to say no, I'm not even going to do that. Okay. Okay. What is our to prove? What do we have to prove?
The angle BOC is twice bigger than the angle BAC.
Good. So we want to show that this one is 2 times that one. Make sense? That's our proof. Okay, our construction is going to be as follows. Okay, construction is going to be the line AO extended extended to D. Okay, so as I say, this is a proof that's really important. All of these proofs that we're doing today, you have to know, okay? But this is a very important one, very likely to be in the exam. Okay, so you can see I'm drawing AO and I'm extending it to D. The reason why I extended this is because I created two triangles here, okay? And I extended it so that I can work with the outside angle of the triangle. Can you see? I've got triangle AOB and an angle BOD is an external angle of the triangle AOB. You see that? Do you all see? Okay. So remember, a triangle, an extended angle is when I take one side, I extend it. It's the angle that the triangle makes with that extended angle. Okay, what is the theorem with extended angles of a triangle? The extended angle of a triangle is equal to, sorry, not the extended angle, the exterior angle of a triangle is the exterior angle of a triangle is equal to the sum of the opposite interiors. So this one plus that one gives me this one. Make sense? The exterior angle of a triangle is equal to the sum of the opposite interiors. And that's basically what I'm going to do. Okay? I'm going to say DOB is equal to OAB plus OBA. Does that make sense? So angle B plus angle A, that's what I have here, is equal to that exterior angle, and my reason is exterior angle of triangle. But, okay, angle OA, so I'm going to put that there, but angle OAB is equal to angle OBA. Why are these two angles equal to each other? There's no hypotenuse because there's no 90 degrees angle here. Okay, guys, this OA, because OA is equal to OB. OA is equal to OB. Isosceles triangle. Why is OA equal to OB?
I think because
They're radii. So you can put that in there as well. OA is equal to OB because they are radii. That makes this triangle AOB an isosceles triangle. Okay? And in an isosceles triangle, the base angles are equal. I suppose what I should have done actually is I should have first said, okay, I'm doing all this from my head, so I know what I'm heading at. Let me first say AO is equal to BO. They radii. Therefore, triangle AOB is isosceles. something like that. Okay. Therefore, angle OAB is equal to angle OBA. Angles, base angles of isosceles triangle. Make sense? So basically what I've said is that this exterior angle is equal to the sum of these two angles, but these two angles are equal. So if I take this plus that, but I'm adding the same thing, I might as well just double that one. Does that make sense?
What will happen to the
Because A plus B,
supposed to the angle?
I'm adding them, but A and B is equal. So if I have one hand, I've got a 1 rand, another hand, I've got a 1 rand. When I add them together, I've got 2 rand. But I could have just said, well, take the one hand and double it. Make sense? Okay. So if I say A plus B, but I can just double A because they're equal. So in other words, angle DOB is equal to 2 times angle OAB. Make sense? Okay. Now, angle DOC is equal, and now we're doing the exact same thing, guys. Exactly the same thing. So all I'm doing here is showing that the exterior angle is double that opposite interior angle on that side, the one on the arc. Okay. So I'm just doing the exact same. DOC is equal to what?
2 times.
No, we must first be doing this whole thing. DOC is equal to, DOC is the exterior angle, is equal to DOB. No, these two angles aren't equal. Look, this is the exterior angle. This is the triangle. Can you see which triangle I'm working in? I'm now in this triangle, AOC. I'm now in this triangle.
So DOC is equal to AOC.
AOC.
Oh, double the.
No.
No.
Plus
Plus
OAC.
OAC. Well done. It's equal to the opposite interiors. Okay, I can't say this yet. This is the conclusion. Okay. I'm still trying to get there. Okay. Exterior angle. Exterior angle of triangles equal to the opposite interiors. Okay. And now I can go through the whole process again. Now I just want to show, but those two angles are equal. To show they are equal, I must first show it's an isosceles triangle. To show it's isosceles triangle, I have to show two sides are equal. The sides that are equal is OC is equal to OA. And the reason there is, why is OA equal to OC? Radii. Well done, you guys seem to be getting it. Radii. Okay, which means that triangle OCA is isosceles. Therefore, angle OA. Wait, I did this wrong. DOC is equal to angle ACO. Sorry, not OCA. ACO. That was a mistake, I apologize. Okay, so in the end I've shown now that these two angles here must be equal. In other words, angle OAC is equal to angle OCA. So angle OAC is equal to angle OCA, and that's because they are base angles of isosceles triangle. Okay, now I don't have space here, I'm just going to write it here, which means now I have also shown that DOC is equal to 2 times, okay, and just make sure you don't want to say 2 times this angle, because in the end what we're trying to do is we're trying to show that this angle here is double that angle there. So I want to show that this part of the angle, this part of the angle is double that part of the angle. So that is the condition. You can go either way. Okay, so DOC is 2 times angle OAC. And now I have 2 equations here. I've got equation 1 and I've got equation 2. So what I'm going to do next is just add those 2 equations. Okay, so I'm going to say, okay, angle DOB plus angle DOC, you'll see why I'm doing that in just a second, is equal to, okay, on this side we've got 2 AOB, 2 OAB, OAB plus, and on this side we have 2 AOC, OAC, 2 OAC. Now look, angle DOB and DOC, look what they are. Here's angle DO, man, and this sketch is getting slaughtered now. Okay, there's angle DOB, do you see it? It's that angle there, plus DOC, that angle there. Those 2 angles make up angle BOC. So if we add those 2 together, we get angle BOC is equal to 2. I take 2 out as a common factor, and I'm left with OAB plus OAC. Now let's look at OAB and OAC. Here's angle OAB and OAC. That's that angle there. Good? Which in total, what would we call that angle? BAC. So this is equal to 2 BAC, which is what I wanted to prove. Okay. You see, it's a long proof. You have to keep your head a little bit, but it's really actually simple. All you do is you extend your, so you connect the point on the arc with the midpoint. That's your construction. And you extend it so that you can have an exterior angle, and you show that that exterior is equal to the opposite interiors, but the opposite interiors are equal, so that's actually double the one at the arc. And then you just do that twice, and you've proven it. And now this one is going to be very, very helpful in the next couple of proofs.